All right, directions are to find the second derivative. Just to let you know, I prefer to use this, y prime for the second derivative and y prime for the first derivative and y double prime for the second. Just a little bit easier to write. You don't have to keep writing those fractions all the time. So let's take the derivative with respect to x of both sides. That should give me 42x plus 2y, y prime, chain rule equals 0. Solve this for y prime. That's what we like to do. For implicit differentiation, if we can, y prime equals, so I'm going to subtract 42x, and I'm going to divide by 2y, and I get my first derivative of negative 21x over y. That's nice. Okay, now for the second derivative. Second derivative uses the quotient rule. Denominator, derivative of the numerator, minus numerator, derivative of the denominator, all over the denominator squared. Let's clean that up a little bit. Okay, now, this is the second derivative. However, we don't want our derivatives in terms of other derivatives, okay? So what I don't like is the y prime. I want to get him out of there. So you're going to do this pretty much every time you do a second derivative with these. So we'll go back and substitute that. And you might notice that you're doing some substitution in these problems to simplifying. I mean, this is the second derivative, but it depends on too many things, right? There's an x, there's a y, and there's a y prime. So we want to at least get it in terms of the original variables x and y. So let's see what happens. Okay, so what's y prime? Well, y prime's that thing. So let's put him back in. Okay, and now without thinking too much, I got a complex fraction here, right? There's a fraction within a fraction. So typically what we would do is multiply both sides by, or top and bottom by y. That gets rid of my fraction. So I got negative 21y plus 21. Well, we got to square that, I suppose. Let's save the big arithmetic. I'm going to factor out this negative 21 just to save me a little trouble. So factor him out. That leaves me with y here. Plus this 21 still exists. X times x is x squared. And what did I forget to do? I forgot to run him through. So that would be y squared. Okay. So let me double check my work. Run the y through, so that would go away. This would be y squared. Factor out a negative 21. That gives me y squared plus 21x squared. I believe that is right. And on the bottom, I got y cubed. Okay. Now, that's our second derivative. We achieved our goal. It's in terms of x and y. However, does anything jump out at you here? 21x squared plus y squared is what? And this happens a lot with these problems. Go back to my original equation. I mean, we don't want to do too much with our substitution. I mean, this is the second derivative, but we can simplify it greatly if I can understand that 21x squared plus y squared is 5. In other words, this is 5. Okay, so look out for things like that. And if I gave you a general, so 5 times 21 is 105, and I get a nice, neat second derivative. Okay, so in general, if I'm giving you advice on second derivatives, take the first derivative, take the second derivative, and if there's a y prime over here, when you take the second derivative, which often there will be, that is, if your second derivative is in terms of your first, then you got to sub him out, and then it's algebra and see if you can find other substitutions, which often you will find that original relationship when you do the problem.